Okay, hi everybody. This is Miss Grosse here. And so I'm gonna do just a couple examples and really just like introduction to a video to kind of help you get through your analytic trigonometry, or trigonometric identities is another name for it. So I will just say that the key point with these kind of problems is that it is purely logic based. And so once you know the rules, you can figure out ways to manipulate them and make them work to your advantage. And so I just want to encourage you and make sure you know that you will get through it and you're going to learn it. And as long as you practice, you will be able to find a lot of success. So to start off, I have an awesome math joke for you. So you see sine Jareen over cosine Jareen equals da 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 da. What do you think the answer is? The answer is going to be, you know, tangerine. Haha. So this might help you survive a little bit longer. When you start to make it a little bit silly, maybe you'll remember that. That's one of our quotient identities. So, so the best way to kind of go through these is to really use your identities. I'll go through them pretty clearly. So just remember that an identity is a law, and it's something that's always true. So I am going to go ahead and first let me make this bigger. Make this a little bigger for you. Yeah, that might mean I'm a little bit rusty with my little tablet that I'm using. Of course, this is going to give me a hard time. Oop, come on. Good times. All right. So, first thing I'll do is just kind of review the. And if you need to fast forward, please go ahead and fast forward. I'm going to go ahead and review our identities that we have. So, our simplest identities that exist are sine theta and cosine theta. And sine and cosine, they come from the fact that on a unit circle, sine theta is actually your y coordinate and cosine is actually your x. So if you didn't know that little connection there, you just kind of see that's why that they're the most simple ones that we talk about. So now, the next kind of identity that exists is a quotient identity. And a quotient identity, remember, quotient is related to fractions or division. So a quotient identity is, for example, tangent. Tangent can be rewritten as sine theta over cosine theta, right? And then the other kind of identity for a quotient identity is cotangent. And remember, cotangent is the opposite or the inverse of tangent. So that would just be cosine theta over sine theta. You all notice I am using thetas. I love thetas. They are my preferred variable. You can use x if you'd like to use x. That is totally up to you. I won't judge you. Yeah, so just pick the one you like more. Okay, so now the other kind of identity that exists is a reciprocal identity. Reciprocal identity, you should know that word from fractions. Maybe when you're in, elementary school, you started learning about fractions, those kind of things. A reciprocal ID is when we're talking about inverses. So, example, sine theta can be rewritten as 1 over cosecant theta, and cosecant theta is 1 over sine theta, right? So these two they're inverses of each other, sine and cosecant. So that's what they mean. All right, so now cosine theta, the opposite of cosine theta is secant. So we could write like 1 over secant theta. And then, of course, the opposite's true. So secant theta could be rewritten as 1 over cosine theta. Love that. And then finally, of course, we've got tangent, right? Sine, cosine, tangent. Tangent, the opposite of tangent is cotangent. So we could write that as 1 over cotan theta. And of course, cotangent will be 1 over tangent. All right. So again, we've got to recap so far. We've got quotient, and reciprocal identities, right? So now I'm going to go ahead and introduce the Pythagorean identities. These are ones that some of you gasp at, and so it's okay. We'll get to it. So Pythagorean identity, um, that should maybe be a light in your head. Pythagorean, just like Pythagoras, Pythagorean theorem. Think of ancient Greece. So there are three main Pythagorean identities. The first one, the main one, is the most core simplified way of Pythagorean theorem. So Pythagorean theorem, if you think about it, is a squared plus b squared equals c squared. So there's a little bit of a pattern here. And so the first Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Y'all also have to excuse my voice because I have really bad allergies, so I'm trying to be as clear as possible. So that's the first identity for Pythagorean. There is a way to get to the next two if you are looking for like a shortcut. First way is just remember in the beginning of this whole thing, I kind of said to you, what's the simplest form of these identities? And the two simplest forms are, and think about it, maybe you remember, maybe you don't. The two simplest forms are sine and cosine. So a way that you can memorize the other Pythagorean identities or just have a little trick up your sleeve, a little toolkit, is to first start by divide that main one by sine squared theta. Like divide everything by it. Just do it and I'll show you a pattern. Trust me on this. So when you do that, sine squared over sine squared, that it cancels out, right, to 1. So it'll be 1 plus, now cosine over sine, we knew earlier from a quotient identity, and I can go right back up here. Cosine over sine, I see is cotangent. So this has a square. So I'm going to go ahead and I'm going to put cotangent squared theta. And then 1 over sine squared is just like saying cosecant. So I'm going to say cosecant squared theta. So this is my secondary identity. Again, they're all of equal value. It's just the way that you're representing it. So again, the first one, let me just rewrite it. It got all botched job. All right. So again, primary identity is sine squared theta plus cosine squared theta equals 1, right? So it's the first one, right? This is our second one. And now the third one, I can actually get by, before I divide it by sine squared, let me go ahead and divide by cosine squared. Again, the simplest form is cosine and sine. So I'm just go ahead and do it, see what happens, and I'll show you how to get to the third one. So I'm going to put this answer right here. So sine squared divided by cosine squared. Sine over cosine is tan. Remember, sine gerene over cosgerene is tangerine. So we have tan squared theta plus cosine divided by cosine. Love that. It's a 1. And then 1 over cosine squared is going to be secant squared. Right. So again, these three are your Pythagorean identities. And I just showed you a strategy for how to, maybe have an easier time memorizing what these are. I will say, like, in calculus, you will have to, like, kind of have these at the top of your head, right? So just be prepped for that and just practice. The more you work with them, the better you'll get. So that was just an intro to kind of what it looks like. Now I'm going to go ahead and I'm going to actually work out some problems using these. And so what I like to do is I write a little cheat sheet at the top of my page. So you all see a date here from when I actually taught this class. It's funny. So let me go ahead and do some problems to help model for you. So I'll start with question 1 here. I have the worksheet. So go ahead and take your time. Go ahead and write down this problem. So sine theta times cosine theta times secant squared theta. So some of you, you might be thinking, okay, like parentheses means multiply. Yes, that's true. But so let's look like sine and cosine, right? We see those. They're the simplest form, so we can't rewrite them as anything. However, secant squared, I know that secant is 1 over cosine, right? So if I write this out, sine theta times cosine theta, and then times 1 over cosine squared theta. When I write this out, so sine times cosine times 1 is going to be sine theta times cosine theta all over cosine squared. I want you to think about this just like if you had like, maybe you had x y squared over, y. We cancel some things out, right? And it would make, our work way easier. So the same thing applies here. So I see that on the top I have a cosine, 1 cosine. If it doesn't have x1, it's just a 1. And I have a cosine squared. So I can actually cancel out 1 cosine at the top and 1 cosine on the bottom. Doesn't mean they both go away. In this case, I'm going to have sine theta divided by 1 log cosine theta. And now, can I rewrite sine theta over cosine theta? Go ahead and look at your identities and see which one matches sine theta over cosine theta. Yeah, exactly. So it's going to be a tangent theta is our final answer. And that is the most simplified form, right? Yeah, take your time with it. If you have to pause, my voice, and kind of take a second and really see it, go back and look at it. It's okay. All right. Okay. Let's keep moving, keep chugging along. If you want to pause and not let me keep talking, if you want to sort it out yourself, do that. Pause me. I won't take offense. All right. So let me go ahead and see. So first thing, right, cosine theta times cotangent theta, times sine theta times secant theta. The first thing, let's just go through and see if there's anything that we can kind of work out. So cosine, that's simple, love that. So I'm just going to rewrite cosine theta. Cotangent, okay, well I can rewrite that, right, as cosine over sine. Sine is going to be, here I'll put little multipliers in the middle too, just for you folks who might get a little mad at me for not doing that. And then secant is 1 over cosine theta, reciprocal identity. You can also put all these ones like over 1 if you want to keep your fractions lined up. I know that's something that some of my my previous students used to really like doing because they like to keep it organized, which is good. So cosine times cosine is cosine squared theta times sine. I'm just going to go in and put the sine right here on the top. On the bottom, I've got sine theta, 1 times sine times 1 times cosine is sine times cosine. And now I'm just going to start kind of marking through and seeing what cancels out. So sine on the top, sine on the bottom, cancels out, reduces to 1. And then cosine squared at the top and cosine. Okay, well, I can get rid of 1 on the bottom and 1 at the top. So I can't all the way cancel it out, which is fine. But I'm going to go ahead and do cosine theta, right? And that'll be my final answer. It's the most simplified way. Right? So some of you might be asking, is there a simpler way to do this? Well, if you know your inverses, right, and your inverse, and inverse means opposite, you might start to see quicker steps to cancel stuff out. So like inverses are sine and cosecant, they're inverses. Cosine and secant, they're inverses. Tan and cotan, they're inverses. So they would cancel each other out. So if I look at this problem, like in the beginning, if I were to start all over again from scratch and not do all this work, we could probably cancel out something here, right? What two are inverses here in this original problem? Secant and cosine. So you could have already like eliminated 2 pieces of this problem by just knowing that these are inverses and what right? Okay. let's keep going. I know I can get on like tangents, pun not intended. I can just keep talking about all this stuff because I'm a big nerd. Um, so let's use what I just talked about, right? So, um, let's go to number three. So question three here is secant theta times cosine squared theta. All right. Well, secant and cosine are inverses. So if I have one secant and two cosines, I can actually just cancel out the secant and one of the cosines. And I'm left with cosine theta. Ooh la la. Now, if you need it worked out, that is okay. So here's how I do it, work it out. So secant is 1 over cosine times cosine squared theta over 1. Rule of multiplying fractions, 1 times cosine squared, cosine squared, cosine has 1, cosine. And then I'm going to go ahead and do my little handy dandy reduction. So 1 crosses out the bottom, 1 crosses out the top. So that I am left with cosine. Different methods, but do we get the same answer each time? Yes. And so I want you to make the choice for yourself what way you think is better. Some folks like the shortcuts, some folks really like to work it out. I'm one of those really like to work it out people because I like things to be organized. And that's just me. So now I want you to pause. If you feel pretty confident, I want you to work on 4 and 5. You can work those out and then maybe check with a partner when you get back into class. Because I'm actually going to go to maybe some more challenging ones. Let me see what I've got on here. Um, okay, I will make a second video to kind of help with some more difficult problems. Okay, so I will be back and I'll do some more with the Pythagorean identities. Thanks. Y'all are doing great. Keep up the good work.